Hi, I'm Lonneke Boels, researcher at the Freudenthal Institute of Utrecht University and mathematics teacher at a secondary school. I conduct this research together with Arthur Bakker, Wim van Doorn and Paul Drijvers. Our research is about developing statistical literacy through histograms, and in this video abstract I unravel what makes histograms so difficult to understand for people. But why on earth do we care about histograms? Good graphs can literally save lives. For example, Florence Nightingale saved lives of many soldiers with her famous polar graph. Nightingale showed that more soldiers died from preventable diseases such as cholera, the blue areas, than from war wounds, the black areas. Thanks to this graph she got extra money for beds, blankets, good food and clean kitchen pottery, which together led to a spectacular decrease of these preventable deaths. So we know that different graphs reveal different aspects of the data. Therefore, it's very important that people can use different kinds of graphs. In this video, I will zoom in on histograms, as these are used quite often and seem easy but are not. Moreover, many people are unaware that they don't really understand histograms, and in our research we unravel why. But which of the following graphs is a histogram? These two graphs look quite similar, okay? The contexts are a bit different, but they are both about weight. But if we have a closer look, we will see that these graphs are, statistically speaking, totally different. More precisely, they have a totally different distribution. To make this clear, we first have a look at how we could estimate the mean of the weight from both graphs. The left-hand graph is a case value plot. To estimate the arithmetical mean here, we can draw a horizontal line, so that the heights of the bars above this line compensate for the missing heights of the bars underneath this line. Phrased more popularly, we make all bars equal. The right-hand graph is a histogram. To estimate the arithmetical mean here, we can draw a vertical line, so that we find the point on the horizontal axis where this graph is in balance. This means that the bars that have the same height but are further away count more. So we take the position of the bars into account as well as its height. So as you can see from these graphs, the way you have to look at it for assessing the mean is totally different. The same holds true for the variation in the graph. Statisticians use the word variability for that. In the case value plot on the left, the variation in the heights of the bar indicates the variability. In the histogram on the right, variability is assessed by looking at the spread of the bars, where you take both the width of the graph and the heights of the bars into account. Therefore, both measures of center, such as the arithmetical mean, and measures of variability, such as standard deviation, look very different in a histogram compared to a case value plot. Many people nevertheless look at the variation in the heights of the bars when they want to know how much variation there is in a histogram. This is one example of how people misinterpret histograms. Variability and center are two of the four concepts that come together in the big idea of distribution. In summary, what our review of the literature shows is that people's misinterpretations of histograms reflect their difficulties to understand two key concepts or big ideas in statistics: data and distribution. And when I say people, I do not only mean students from primary to tertiary and beyond, but also their mathematics teachers, mathematicians and researchers. In this video, I only explained one of many misinterpretations that point at not understanding the big idea distribution. But we think that problems with the big idea data might even underlie many problems with distribution. This did not get much attention from researchers yet. If you want to find out more about what the problem is with the big idea of data, take a look at my other video. Thank you for watching this video.